Officially in the home stretch of Power Forward. So we will continue our discussion of rate design. This panel is entitled Optimizing Value for the Customer and System. We are joined yet again by Paul Centolella, President of Paul Centolella and Associates LLC, James Sherwood. Do you go by James or Jim? James. James Sherwood, who is a manager of the Rocky Mountain Institute, and Doug Staker, who is the Vice President Global Sales for Demand Energy Networks. Thanks to all three of you for joining us. Paul, you're up.
Okay, thank you, Mr. Chairman, commissioners, members of staff. It's great to be back here again and to talk about a complex topic of rate design. When we have dealt with rate design, we are still in large part back in a world of vertically integrated utilities and principles that come from sources like Bond-Bright that was originally written in 1961, updated in 1988, is now 40 years old, and even that second edition came out in the same year that Fred Schweppe and two of my colleagues at Tabors Karamanos, Michael Karamanos and Richard Tabors, wrote the first major piece about how to do LMP pricing and spot pricing for electricity. We didn't have organized markets the way we have today. It was also the same year that the first conferences occurred about how to design a commercial internet. We didn't have the digital technologies that we have today. We didn't have ubiquitous communications. We didn't have smart devices. We didn't have electric vehicles as they're coming forward. So we need to think again about how to move from these historical principles where we basically took embedded costs, we allocated them to rate classes, and then we functionalized them by customers or by demand or by energy and used that to construct rates. And rethink about what is going to be the appropriate way of thinking about rate design that creates the optimization that this commission is interested in going forward in a world where we have distributed energy resources, we have smart devices with intelligence out on the network that are going to be looking at this in a very different way from the way generators may have looked at what was going on in the past. So what I want to do is talk about a couple of fundamental challenges that we have going forward. The first is how to efficiently integrate the demand side and the distributed energy resource side of the market so that we begin to capture the efficiencies, we begin to levelize the demand, the load shape, begin to create better asset utilization and real economic benefits from that. And then secondly, the challenge of having said that, we still have parts of the system, transmission and distribution, that are functionally natural monopolies. And how do we recover the costs of those monopolies without distorting the efficiencies that we've created, because we're now concerned about sending efficient price signals and rates to the demand side of the market and not just using them as a way of collecting revenue. And I'm going to talk about this as an economist from an economic perspective, recognizing that there will also be some questions that I'll talk a little bit about at the end that are really equity questions about which economics has much less to say than it has to say about how to efficiently optimize a system in which demand is now much more actively participating in the network. So I'm going to build, at least in this first part, on some of what we talked about on March 8th. For any of you in the audience or the millions at home who were here on March 8th, I would encourage you to go back and listen to the last couple of panels on market design, because we really talked there about the importance and the value of markets to deliver locational marginal prices and what that might mean in terms of the efficiency of the system going forward. So with that as background, what I want to do is begin by talking about some of the basic economic principles that you ought to be thinking about as you think about rate design going forward over the next decade or so, as you're moving more towards having more distributed energy resources, more responsive demand, more electric vehicles in the market, and then talk about how you deal with this question of recovering the residual costs that are not recovered at either market prices or marginal cost-based rates, and conclude with a few comments about equity. So when we think about rate design in this context, we can think about, first of all, at in terms of bringing market price signals in, we have reasonably good marginal cost-based market price signals at the RTO level for in the energy markets and the ancillary service markets. Now, today they're mostly there for supply, but I'll talk a little bit about how we could bring some of that to the demand side of the market. Then there's the question, if you're not yet at the point of moving to a fully distribution level market, can you begin to emulate some of the things that would be marginal costs in the distribution system as you're designing distribution rates going forward? And finally, then there's the question of that we talked about 2 weeks ago of when and how do you move to a distribution level market. So those are the things that come in terms of playing out the market principles. This becomes important for really three fundamental reasons. One is you have to get those price signals right in order to reflect the time and location-specific value of the specific products. And remember, there are really only three fundamental products that a DER can provide. It can provide real power, it can provide reactive power, or it can provide some form of reserves, and generally it can only do one of those at a time, and you have to trade off which one you're going to do as a DER. So how can we create rates and price signals that facilitate those kinds of trade-offs in an efficient way, as well as provide the right price signals for investment, for siting, for orientation if you're talking about PV and the general operation of DER. Second, you want to avoid unnecessarily socializing DER costs and risk, or and also the regulatory burden of trying to set the value of specific DER administratively. Commissioner Johnson, I know we talked 2 weeks ago and you said, well, creating a DSO and some of these market concepts seem hard. Well, if you want to think about something that's hard, think about having to forecast 6 or 7 different variables for each line segment within each distribution system, and then try to figure out what the value of a DER is going to be at that point on the system going forward, and try to do that accurately and right. Now, that planning exercise, that's a very hard exercise, and so to the extent that you can actually take advantage of markets to begin to assess those values, that's actually in some ways much simpler. Finally, you're going to be dealing with a different kind of set of technologies on the distribution grid. When you think about electric vehicles, when you think about smart buildings and smart thermostats and all of these things that now have intelligence, what they are going to attempt to do is to continuously optimize vis-a-vis current and their anticipation of future prices, plus a dynamically changing set of requirements for the customers that they serve. You know, when do I need to drive next? What are my preferences around temperature? Does it change throughout the day? All of those things will come into these smart systems, and they will be much less likely to be able to respond to, as we talked about 2 weeks ago, to demand response programs, because in the best case, they will have already begun to reduce demand during what they anticipate to be high price periods before you call an event. In the worst case, they will have anticipated that you're going to call an event, increase their usage during the baseline period, and not give you any real reduction relative to where they might have been when you call the event that they get paid for. Or as you think about a world in which there might be millions of smart devices, hundreds of thousands of electric vehicles, all engaged in this optimization, it becomes much less tractable to think about the fact that you're going to have a central dispatcher somewhere who's going to know all these dynamics and be able to efficiently dispatch. So rates and prices and the information that they send become much more important as we make this transition to a more distributed world. So this creates this kind of fundamental tension between two elements of rate design. On the one hand, there's a bedrock principle of microeconomics that says economic efficiency is going to be maximized when prices equal marginal cost. On the other hand, when you're dealing with transmission and distribution, these are natural monopoly services. That means that average and marginal costs tend to decline as you do more of them, which means, in turn, that a distribution utility is never going to be able to recover, or very seldom going to be able to recover, its full revenue requirements at prices that are equal to marginal cost. So what that in turn means is that you have to think about rate designs that, all else being equal, seek to combine a dynamic rate that reflects changing marginal costs with an ability to recover the residual costs of the monopoly services in rates that minimize the distortion of the efficiency that you've already created by pricing at market or marginal costs in the distribution system. So these are the two challenges that you face, and I'll talk, in a few minutes about some ways in which you might try to address them. But first of all, let's talk a little bit about what we mean by marginal cost. What an economist typically means by marginal cost is they mean the cost of a very small, some people would say infinitesimally small, increase in output, in short-run output, because you're looking at something that is very time, location, product specific. You're trying to affect the choice of, do I operate and cool my building now, or do I do it 2 hours from now? That's a very specific, granular kind of question that rates are trying to ideally impact. As a result, we get two kinds of issues that often come up when we think about marginal costs. One is you see people that go back to the terminology of integrated resource planning or PURPA, and they talk about avoided or long-run marginal costs. These are very general concepts which were useful when we were in a planning context thinking about big resource investments. They're much less useful when we're thinking about how to facilitate the efficient operation of demand and DER that is on the grid and that is responding in real time to what's going on. We also have to bear in mind perspective. Even though you may see transmission costs that are billed on a per kWh basis, they are still largely fixed costs. They are not marginal in that sense. And so you need to understand what the marginal component is. Finally, I just want to mention the issue of social or societal costs. As an economist, the ideal would be to have the costs of the environment built in through a market mechanism, whether that's the kind of cap and trade mechanism that we did for SO2 that I helped design back in the late 80s and early 90s when I was at the Commission, and then helped EPA design their trading mechanism, or whether it's something like the carbon dividend proposal of that Jim Baker and George Schultz and others have put forward. But we don't have that, and so the question becomes, what do you do about that? The position that I took when I was in your position and we were looking at this question of straight fixed variable rates is to say, let's move in that direction, but let's not reduce the kWh charge below something that seems representative of societal marginal cost. Now, what does that mean? Probably, depending on what you think, what resources on the margin, how much value you want to put on the externality, maybe something in the 1.5 to 3 cent a kWh basis might be a reasonable reflection of what societal marginal cost, the societal component of marginal cost. Needless to say, in many rates there is much more fixed cost that's being recovered on a volumetric basis than that level. So, we've had some discussion earlier today about time-varying rates, and I want to talk a little bit about time-varying rates versus market rates. So time-varying rates are things like time of use rates, critical peak rebates, critical peak pricing, and as Dave Littell talked about earlier this week, there's very good data from a lot of experiments that shows if you use those kind of rates, you can in fact have a material impact on reducing peak demand. The other kind of approach is a market-based rate, a real-time pricing rate plus a capacity adder, or as we talked about 2 weeks ago, a block and index rate, and I'll come back to that a little bit more, that provide much more information about how to continuously optimize the power system over time, because they're not just focused on peak. And in fact, there are a couple of studies which are in my references where people have looked at how much less information is available in a time-varying rate versus if you took account of all of the dynamics that are actually going on in energy markets. And depending on which study you look at, somewhere between 23% and 6 and 13% of the information will be captured in an idealized time of use rate where you had perfect knowledge of what those prices were going to be in advance and could set a monthly time of use rate on that basis. So there's a huge loss of information. The question is what to do with that, because you essentially have two different types of structures that are serving two different objectives. The time varying rate is really focused on behavioral responses to a limited number of events that occur throughout the year. The real-time price, or the market-based price, is looking at how you continuously optimize and how you engage the automated responses of smart devices. So what I'd like you to do for just a moment is to think forward about, okay, we're in this environment, we have many more distributed devices, many of them smart, many of them trying to be able to optimize for customers. What would we want as an efficient default rate that could capture the maximum benefits? And recognize that I'm sort of projecting forward with the idea that over the next 5 years or so, what you ought to be thinking about is some experiments that help you figure out what precisely this looks like. But let me give you an example of what you might think about if you were to think forward about that. You might think about a hybrid that combines some of the best benefits of a time-varying rate in terms of providing education and notification to customers about when they ought to change their behavior, with something that was more like a real-time pricing rate that could automate, that could elicit the automated responses of smart devices. What that might look like to make this simpler is something like a two-part block and index rate, which is something Georgia Power has been using for its industrial customers since at least the 1980s, where customers would pay a fixed price to pre-purchase a standard hourly load shape. And whether or not there's 3 or there's 10 different standard hourly load shapes, depending upon how you classify customers, that's one of the things you would want to think about. But there would be some standard hourly load shape. And that would be purchased at a fixed price. If they managed to use less than that, they would get a rebate based upon what the real-time price is. If they happen to use more in some hour, they would pay the market price just for their incremental usage. So they'd have a pretty good idea what their rate is going to be, but they'd also be getting the price signal that tells them and tells their devices to optimize their usage over time. And as you move forward, the default service auction would move from its current requirements-based to some form of block-based, and you could continue to do auctions to implement it. What might you expect in that world? Well, first of all, you would likely see auction prices decline relative to what they would otherwise would be, because suppliers would no longer be responsible for a correlated quantity and price risk. You would see consumers have greater control, something that we know from the AEP real-time pricing experiment that was talked about this morning, that consumers really value. And you would see a retail market animated to provide new kinds of services to help customers better manage their bill. So, looking forward, how might you take some incremental steps? Some of these we talked about 2 weeks ago in terms of the bulk power market. You would want to reduce RTO settlements that are based on load profiles and move to actual demand. You'd want to consider whether or not RTO prices should be nodal and interval rather than zonal and hourly. And you might want to follow up the example of what's been done with energy efficiency and RPM and figure out a way to have dynamic prices become a component of the forecast that PJM does to determine RPM requirements. You could also begin to think about what this means at the distribution level. First of all, we've had some discussion of using DER as non-wires alternatives, and what I would say there is if you're going to contract for DER as a non-wires alternative, you ought to pay for what it is that you're actually after, which is the ability to dispatch those DER at times and locations where you actually need them, rather than a broader DER contract. Second thing that you could do is you could consider adding a variable component for marginal losses into the distribution rate that's comparatively easy to calculate and could be done relatively simply. Finally, you might want to consider some surcharges for hotspots where there are constraints or equipment impacts. Those could be, if you so desired, revenue neutral in the sense that you would reduce residual revenue requirement in terms for in recognition of having a surcharge at particular times and locations to shift demand. Now, let me talk briefly about how you begin to recover the residual revenue requirements. So here you want to do something that minimizes the impact on the efficient allocation of resources. There's some ways to do that that are relatively efficient in the sense that they don't change the relative demand in the market. A customer charge is one way of doing that. For a subset of CE&I customers who have relatively flat loads and limited flexibility, a demand charge can act much like a customer charge, a fixed charge. But there's another option that I think has not really been considered in this industry in the United States. It is used in parts of the EU, and it's used in other industries that are either network industries, like telephony and the internet, or that have very high fixed costs and very low marginal costs, like in software, and that is the option of a subscription pricing, where there's some base price that everybody pays, but you have flexibility to set pricing for different additional levels of service if people want to have higher demand levels associated with their service level. And that becomes a way of creating more flexibility than you have with a demand charge, and also beginning to align the commitments of customers and the utility up front. So that's, I think, an interesting option that probably deserves some exploration here. There are less efficient ways of going about that, higher volumetric rates. That's going to discourage economically efficient use of electricity in electric vehicles. It creates an uneconomic incentive in some cases for distributed generation and increases some of the net metering subsidies. Demand charges, particularly if it's a uniform demand charge per kW, this creates much more volatility on the customer side and is more difficult for customers to manage. Minimum bills, they're essentially, if they're binding, it's a zero price during the first block for marginal usage and then a big increase in price plus a fixed charge. It's not a particularly attractive rate design. Finally, we get to the question of equity, and equity arises in many instances in defining customer classes and allocating cost to customer classes, in deciding, for example, how you might structure a subscription rate. And here there are different perspectives that come into play. Economics plays somewhat less of a role. In fact, I like what Peyton Young had to say, that essentially equity is what societies use to resolve distributed problems where efficiency and economics by itself doesn't yield any specific determinate result. Now, I cite Brombright here because he's in some ways not that different from the economic argument, from the efficiency argument. He says, well, you treat people who are similarly, you treat people who are differently. But he adds something that I think is kind of interesting in our current context of thinking about net metering, which is what he calls anonymous equity, and that is that no ratepayer's demands can be diverted away from uneconomically from the incumbent by a potential entrant. Interesting perspective, given that it was 40 years ago that he wrote that. There's also, I think, a real argument about gradualism. We heard this a little bit this morning. What do you do about someone who's made a substantial investment based on the assumption of a continuation of one set of rate design, given that you have a more efficient option that you could pursue going forward? You can ameliorate the impacts on that customer, but know that there will be real costs whenever you do that. So that's a kind of judgment call that you have to realize. And finally, there's the John Rawls social justice perspective, which talks about benefiting and protecting low-income customers. I'll say one just brief thing about that. You oftentimes hear the argument that low-income customers can't benefit from time varying or dynamic pricing. The data really don't seem to support that. They do seem to respond to price signals, and they do in general seem to be made better off. And you can look at some of the citations there for further information about that. So that's my initial presentation. I look forward to your questions.
Paul, thank you very much. James?
Great. Thank you for the opportunity to speak here today. I'm James Sherwood. I'm a manager with the Rocky Mountain Institute. And I'm going to build on what Paul said in the excellent conversation this morning and kind of provide a synthesis of what we've seen in our work across the industry, across the U.S., talking about best practices and industry trends on rate design reform. So I'll start off, again, drawing really from our national experience here to talk about industry trends, look at best practices for, in particular, time-based rates and demand charges, and then kind of draw the line between there and Ohio and think about what some key considerations are for next steps on rate design that we've seen kind of across the patch. So just by way of introduction on Rocky Mountain Institute, since I know I've met some of you, but not all of you, we are a nonprofit founded 35 years ago. We call ourselves a think and do tank. We do a combination of research and thought leadership, as well as consulting work. So kind of both the research side and the implementation side. Our electricity practice in particular does a combination of research and analysis, so we provide a lot of reports, also work directly with utilities and commissions across the country. So looking at the rate design situation kind of across the US, I think we've heard a lot of these trends come up already today, but the landscape is evolving. In particular, load profiles are diversifying as things like EVs come onto the system. New technology is increasing the capabilities both of utilities in the case of AMI, as well as customers in the case of things like smart thermostats. And electricity demand growth is flattening both in Ohio as well as nationally. So what that means is that there's some implications for rate design. In particular, current price signals aren't adequate. They're not conveying the information in a useful way to allow consumers to respond effectively. The existing rate design toolkit, so the rates that most utilities currently have on their books, is pretty limited. And there's a misalignment developing between costs and rates. All that is to say something needs to change going forward. So what we've seen kind of across the US is the utilities and regulators are grappling with a similar set of questions to those being asked by the Power Forward initiative here. I'll just kind of run through some of those. This is probably going to be pretty self-evident given the conversation and that this is day 12 of 12. So first of all, one of the questions that we see is how do you support effective adoption of new rates, time of use rates, demand charges, et cetera? What are some of the best practices for implementation? How do you design them well? How do you ensure that customer education and protections are in place? How do you balance utility services with competitive market opportunities? What services should be provided by utilities versus market entrants, et cetera? What portions of rate design in particular can be turned over to the competitive market? And how do you ensure that you have appropriate oversight and guardrails for competitive services here? And then what's the role of demand-side resources? So both energy efficiency, demand response, et cetera. How do you really utilize those in a way that supports the grid? And what are the right compensation mechanisms for DERs? Again, all things that have been talked about here already. So as far as where you go with that, I think kind of it helps to start with basics. And we've heard, I think, almost every presentation started with some discussion of policy objectives. And I won't repeat a lot of that. I think maybe I'll frame it a little bit differently, which is to say, traditionally, there have been a couple of key policy objectives that have really been emphasized above others. So there's obviously the long list of bond right principles and others, but cost recovery and fairness and affordability and simplicity have really been kind of the emphasis with rate design. What we've seen the trend going forward is that utility or regulators that have re-examined rate design have really looked at this through a new lens, kind of a customer-centric lens, an innovation-centric lens to say, what are the policy objectives that really align with this new way that we're thinking about rate design and thinking about the grid? So that includes setting objectives that reflect customer choice, that enable innovation, that encourage demand management, that provide for some level of environmental performance, and then economic efficiency, of course. So that's not necessarily reimagining the existing principles. It's sort of applying them in a new way that really makes sure that rate design is going to meet the objectives for what you want to see going forward. So then, as far as where you go with that, how do you take next steps? When RMI has looked at this and sort of thought about what a pathway could be for rate design going forward, today most customers have a pretty simple experience and a pretty simple rate. So they're in this chart on the screen here, they're kind of in the bottom left quadrant. And ideally, what you would want to see is customers, again, having a simple experience, most customers that is, and a relatively more sophisticated rate that's better achieving those policy objectives that you've set. Some customers who really have a lot of technology or special capabilities might want to have, a more complex customer experience. So a customer who's sitting on a couch and has all the smartphone apps and everything at their disposal, maybe they fall into that upper right quadrant. But the majority of customers should still have a pretty simple experience. And that can be enabled by technology, but kind of thinking about that as an end state, I think, is helpful. And then as far as what gets you there, I think it's more of an evolution than kind of a one-size-fits-all here. So in the near term, there's rates that could work like time of use pricing, which is already in place and being expanded in some states. Potentially demand charges, things like distribution hotspot credits, which could start to get at the distribution side of things. In the longer term, is more technologies in place, more experience has been had with some of these new rates. Things like real-time pricing, unbundled rates that do more attribute-based pricing, distribution locational marginal pricing become more reasonable options. So thinking specifically about time-based rates, and maybe I'll pause there because I think there's a lot of terms that have been used today as well as in the industry around time-based rates, time-differentiated rates, time-varying rates. I think they're all kind of interchangeable. When I'm saying time-based rates, that includes any rate that includes a time-varying component. So kind of using those interchangeably, but that's everything from time of use to real-time pricing and many things in between. But within that, there's a wide range of options that you can do that have different levels of complexity and sophistication. So at the lower level of kind of price uncertainty, you have time of use rates. So rates are set well in advance, and customers kind of know what's coming. So a year out, they would know what the price is going to be at 3 p.m. on a Wednesday afternoon. You can add things that increase the complexity there. So you can add critical peak pricing, which adds a certain amount of additional price uncertainty. And then you can add a whole host of other things like flexible duration, variable peak, that can combine to continue to increase the complexity level, all the way up to real-time pricing on an hourly basis is sort of the other end of the spectrum. When we've looked at the actual effectiveness, and Paul commented on this with his presentation, we've sort of stepped back and done a survey to see, are time-based rates actually effective, looking beyond opinion, looking for some facts. And what we found is that, the experience shows that well-designed time-based rates are pretty effective. So they can have really high peak reductions. I'll talk a little bit more about that in a minute. High levels of customer satisfaction and retention, and kind of with the right amount of customer education, they can be very successful. At the same time, if they're not designed well, they can flop. And I think lots of states have seen that. I think some of the past time of use experiments in Ohio have sort of seen that as a result. The way that we've kind of thought about how you would differentiate between those is to look at time-based rates through this lens of several different dimensions. I'm not going to go through all of them, but what we've done is kind of outline what the key design choices are that go into determining whether a rate is going to be successful or not. And these include things like how cost components are included, what the peak to off-peak ratio is from off-peak prices to peak prices within the rate, what kind of enabling technology is included, how customers are enrolled, et cetera. And you can use this to look at both existing rates to sort of see where they sit along all of these different design choices, as well as rates that have been proposed. So this can be an effective tool, both examining existing rates as well as looking at new options. Just to kind of illustrate how important those design choices can be, here's a couple of examples of what kind of outcomes come depending on the design choices that are made. So on the left-hand side here is the peak to off-peak price ratio and the resulting peak reduction that has been seen from rates that use different levels of peak to off-peak price ratios. And generally what we see is that as you increase that ratio, you strengthen the price signal. Customers respond by reducing their peak further. So an ineffective rate might have a very small peak to off-peak price ratio. It's not sending a very strong price signal, ultimately not achieving the objectives that you probably wanted to achieve with it. On the right-hand side, similarly, the difference between an opt-in and an opt-out rate design. And opt-out typically see much higher levels of customer participation and retention. Opt-in, it's a lot harder to get customers to sign up. So if your goal is to have large levels of peak reduction, an opt-in rate would be, or an opt-out rate, would be the right way to go. We've also done the same kind of research looking at demand charges, and specifically looking at demand charges for residential and small commercial or mass market customers. And I think what we've seen here is that there's, in theory, demand charges can achieve a lot of the same objectives as time-based rates. In practice, we haven't seen a lot of evidence that really supports one way or the other. whether they are effective at achieving the desired outcomes. So there have been a few studies that were done 30, 40 years ago. Arizona Public Service has done some work recently, but there isn't really any conclusive evidence here one way or the other on whether they achieve the right objectives. But at the same time, there's a similar set of design dimensions that you can go through and examine an existing rate or a proposed rate to try to think about whether it's going to achieve the objectives that you want, including things like does it use a ratchet mechanism? Is it coincident with peak, or is it a non-coincident peak demand charge? So again, kind of looking back at industry trends, what we've seen is a lot of states and forward-looking utilities are really turning toward time-based rates and thinking about how they can use those to do two things in particular. One, better reflect a changing grid, and two, encourage demand flexibility. So a couple of the examples that we have here include Hawaii Electric in Hawaii, obviously, Excel in both Colorado and Minnesota. And all three of them have proposed new time of use rates that do a couple different things. They shift the on-peak period to a time of day that better reflects their grid conditions. So all three of these states have had different levels of solar and wind and other resources coming onto the grid that have kind of changed the cost profile of generation. And they've also thought about how to make that more effective through a stronger peak to off-peak price ratio, a shorter on-peak period, et cetera. So just to kind of draw out one of those specifically to show how it's changed, Hawaii, where there's been a huge uptick in solar, as has been widely reported over the last 10 years or so, their old rate was pretty flat throughout the day and then had a strong on-peak price signal in the late afternoon and early evening. As solar has increased, that kind of cost profile has shifted a little bit. So they've introduced a new rate that has an off-peak period during the middle of the day when there's excess solar on the grid, and a mid-peak or sort of a shoulder rate in the early morning and evening. And then in the early evening, the on-peak rate is pretty similar to before. So it's kind of providing a stronger price signal to folks to kind of shift their usage to the middle of the day. So from all that, thinking about how you could move forward with rate design, one of the things that we've sort of proposed is that there's really a set of steps that, regardless of the rate design that you want to move forward with, that you would want to think about proceeding down. At the top of the list is setting really clear objectives, and this is not Ohio specific, this is everywhere. Having the right set of criteria to design against is kind of critical here. Second is leveraging resources from across the country, building on the experience in other states that have done this, so California's and New York's that have been pretty proactive about thinking about time of use rates, have a lot of lessons learned and mistakes made that you can build off of. Doing a comprehensive evaluation is another one, both of existing and experience with time of use rates or whatever rate design it is, and then also doing a really comprehensive evaluation of proposed rates to make sure that they are achieving those objectives that you've set forward. Thinking about pilots and ensuring that they follow explicit best practice, I'll talk a little bit about that in a minute, as well as customer education. These are two kind of key areas to think about. Enabling technology as well, thinking about how you can better utilize smart devices within the design of a rate program. So looking specifically at pilots, pilots kind of get a bad rap these days because there have been so many of them and there's a lot of fatigue, at least that we've seen. RMI has done some work working with utilities to really examine some more innovative pilots out there and see what the key best practices were that they did to ensure that they achieved the right objectives and actually had beneficial outcomes. The things that we found from looking across these utilities were these 5 kind of areas to focus on. Strategic planning, making sure that right from the outset there's clear priorities and goals, and that the pilot is designed to fully achieve them. So making sure that you know what you're trying to do with it. And that sounds kind of obvious, but when you look at a lot of pilots, they don't really do that from the outset, and they're not effective at really getting to an end state that tells you the information that you need to move forward with a broader program. The second one, organization. So this is ensuring that within the organization that's implementing the pilot, whether that's a utility or a retail provider, that there's clear organizational leadership buy-in, and there's dedicated resources. So you actually have the right level of leadership support and you have the right team that's working on it. Cross-utility collaboration. This could be within a state. So if For instance, you had all of the IOUs in Ohio working on designing a certain type of rate, ensuring that they're collaborating to make sure that they're sharing best practices. Also thinking about interstate collaboration, so utilities working with utilities in other states that have tried to do similar types of rate designs. And let's see, designing to scale. So again, ensuring that the design really supports this pilot moving toward something at a larger scale. So a lot of pilots, you know, they provide some interesting information on a small scale, but then they burn out. There isn't really a clear plan for how they go from small scale to large scale, which ultimately is not helpful because then you have to reinvent the wheel to do a larger scale program. Stakeholder engagement, again, I think really the lesson here is that pilots tend to do better when they have more stakeholder engagement up front. So when a lot of different stakeholders have their views put into place, it can be challenging, it can slow the process down, but it results in a better product and one that's more likely to be successful. So then the other point I wanted to make was around customer education and protection. So I think this was mentioned earlier by First Energy. You know, their kind of experience was that education was key in getting their CPP and PTR rates off the ground and getting buy-in. Just creating a great rate design doesn't really do a lot of good if customers don't know how to access it and how to interface with it. Baltimore Gas and Electric, their peak time rebate program, I think has been discussed a little bit over the last couple days. Aside from what you think of it kind of as whether it's a good program or not, it has been really effective at getting customers to sign up. So they've done a really good job with customer education and recruitment, both at the outset and then kind of on an ongoing basis to ensure that customers continue to engage with the program and really understand what's going on. And then protection as well. This can be anything from simple things like having an opt-out mechanism, as well as to more complicated mechanisms that might be necessary for a retail provided rate. So I think with that, I will stop and I look forward to the discussion. Thanks.
James, thanks very much. Doug?
Good afternoon, Mr. Chairman, Commissioners, staff. Thank you for the opportunity to speak here. I'm going to talk to you today about a pilot that we have put together in New York for commercial industrial accounts. And it is based upon a standby design, so I'll take you through in detail, but just a little bit about who I am and my background. I work for a company, one of the largest utilities in the world, a company called Enel. They acquired the company that we built previously, a distributed energy storage company last year, and we've been part of the Enel group, and it's been interesting. Enel serves 65 million distribution companies or customers around the world. And our leadership believes that as a distribution utility and a generation utility that the market's changing, so we better figure out how to serve our customers differently or somebody else will. A little bit about my background before I started, co-founded Demand Energy, a company focused on energy storage. I helped build a company called Itron, which is one of the leaders in smart metering. I was part of the executive team that really grew Itron into what it is today. So I was very pleased to hear lots of talk about AMI and smart metering. That means that the message that I delivered over 23 years ago is starting to take place. And to think about, just being patient in this marketplace. A little bit about my personal background. I'm a third-generation power engineer. I grew up in the power business. My wife likes to say, I grew up in the power business like a farm kid grew up on the farm. My uncle got first patents in time of use metering in 1976. So at my household, my mom understands time of use metering. A little twisted. So let me talk about how we came up with this concept and where it came out of. I like to say that, we got a little automation going on here. I like to say that, we're trying to build the digital power grid based upon analog rate design. And so one of the things that we discovered when we first went into New York and we started putting storage into buildings is that there's opportunity in New York City, not only just for, they have high demand charges, but also they have a very extensive demand response program because building to meet the peak in New York City is a challenge. New York City uses 14 gigawatts of peak power, which is a quarter of what the state of California uses in energy on a peak day. And if you think about that, New York City is not that big of an area, and so it has extreme energy density. So being able to leverage these systems, and inadvertently, when we went in and put a storage system into a large building that was on a commercial rate, Con Ed came to us and they said, we apologize, but we need to move you on to standby. And we thought, okay, what does that mean? And fundamentally, what it meant was that the rate that we were on, this time of use rate that we were on, basically moves us from a charge where 50% of that is based on energy and 50% on capacity or demand, to a rate that's based on about 90% on capacity with only a 10% volumetric charge. We thought we were toast once we got moved to that rate, but what came out of this was a very interesting perspective that we've been able to leverage. And then we were able to develop this alongside with Con Ed and the Public Service Commission even further to provide both time and locational based pricing. So what's unique about the standby rate is it has a daily as used charge. So every day, and it only applies Monday through Friday, and it applies from 8 a.m. to 10 p.m. And so every day we have an opportunity to shape the building load to reduce their demand charge. Now, if tomorrow there's a demand response event that's going to be called and we're going to change our operating profile, where we're going to just do a bulk discharge throughout a 4-hour period, we only lose 1 day of demand charge savings to have that flexibility to move to a demand response program. And we found that very beneficial. So as we started to look at this, and we knew Chairman Audrey Zibelman of the Public Service Commission, we started talking with Audrey about this design. And we said, we think we can do a little better. We think that there's ways to make it even more granular from a daily design into an hourly design. And we've been involved in hourly pricing from a supply perspective for our customers. So we manage these systems to take advantage of the price signal that we can get on a supply side. So we've moved all of our customers onto a day-ahead index rate supplied by a retailer in New York City, because we've proven to our customers that a day-ahead hourly price overall drives better savings for them, and our systems can automatically take advantage of that price signal. So one of the things that we like to point out when people talk about how are we going to move forward and look at these opportunities in the DSO, how do we develop pricing or marginal costing and all that, again, we like to point towards what the ISO has done. This is just a snapshot of their day-ahead pricing that has basically 3 components: the supply component, the LMBP price, the congestion, and the losses in the system. And we take that information every day into our system automatically. We get a feed from the ISO, and at 4 in the morning we receive that file, and we know what the hourly pricing is going to be from midnight tonight to midnight tomorrow night. And so that allows us to have a price signal and some optionality about when best to charge, when best to discharge. Along with, we have our daily demand charge for the distribution company, so we know what hours from 8 a.m. to 10 p.m. when we can drive the most savings for the end user and provide benefits to both the ISO grid and the distribution grid. The thing that we find interesting, and lots of discussion, that I've noticed that the discussion naturally goes to the residential class, but I would challenge and say, I think if you look at the commercial industrial customers, they make up 10% of a utilities customer base, but they represent about 40 to 60% of the load. So this is a picture of the load duration curve in New York. And this is a comment that came out of the REV proceeding from the PSC Commission about, if we could reduce the top 100 hours of usage, we would drive $1.2 to $1.7 billion in saving. Building to meet the peak is that marginal cost is very expensive and has very low utilization. So we think that by focusing along with this pilot, that we can demonstrate that if we can get commercial customers engaged, they're very interested about their operational costs. We run the system for them. They don't have to be educated in that. We do it as energy as a service model for them. We think all those benefits will be shared across the ratepayer. So, and I would say that as you look at pilots and ideas here, think about maybe walking before you run and think about the commercial accounts. Or if there are those in the residential market that would like to participate in something like this, make it an opt-in account and to be able to leverage this concept here. So one of the things that's interesting in New York City is we have 4 peak time zones here. We have peaks that occur from 11 to 3, 2 to 6, 4 to 8, and 7 to 11. Now, the peaks that are from 11 to 3, or this is a picture of Brooklyn, but in Manhattan, Wall Street, Borough Park here is where the city government is, and also most of the commercial businesses. So I would say downtown Columbus here probably has a very similar peak from about 11 to 3. When you move into other areas like into Midtown Manhattan, or in this diagram in Bay Ridge and Park Slope down there, those have more industrial mix or retail mix in there. So a lot of that load, like if you think about Saks Fifth Avenue has a 2 to 6 p.m. peak. And then you'll move into areas where you have a lot of restaurants, a mixture of commercial and some residential. Those tend to peak from 4 to 8 p.m. And then in the purely residential, like in the famous Brooklyn Queens demand management zone that we have projects in, that's 90% residential loading in there, and that tends to peak from 7 to 11. So we're starting to leverage with Con Ed pricing that coincides with the network peak in these 4 different time zones. One of the things that I've heard, and I've heard this a couple of times in the discussion here, is that most people believe that distribution costs are flat, are fixed. And one of the points we've liked to shown is that when we look at distribution losses, especially dynamic losses relative to load, they're not fixed, they're dynamic. And if a lot of loss analysis is done in a static fashion or an over time period, they're really, as this graph shows, average seasonal losses. Con Ed sees just about almost 10% line losses over a summer. Now what's important about that is that's usually measured by energy generated versus energy metered as far as use, and they look at the differential and determine what that loss is between there. But that doesn't take into account any of the dynamic elements. So when you look at a load profile and the ratio of the trough to the peak, when you have a ratio of about 1.4, 1.5 to 1, that may be the load differential, but really line loss is a function of the load squared. And so what you would see is the line loss at peak is over twice what the line loss is during the trough. So that percentage that showed that Con Ed's average line loss was about 10% in the summer means that at peak it's about 13%, and in the trough it's about 7%. So if we could shape that load proportionally, fill the trough, flatten the peak, and gain about a 3% efficiency, that's almost close to 400 megawatts of loss we could eliminate. So looking at line losses, and the reason in distribution systems the voltages are lower, they're much higher than in transmission systems, and I think a contributor to the marginal cost and where it drives value. So what we had proposed was basically to take a modification of the standby rate, which had fundamentally 2 charges, one from 8 a.m. to 10 p.m., and then a second charge that was about, I'll give you some hard numbers here. The 8 to 10 charge was $1 per kW per that time period. And then there was a second time period from 8 a.m. to 6 p.m. that was about 50 cents for the peak. So 2 time periods. What we ended up with was that we took that 8 to 6 p.m. time period and we shrunk it down to a 4-hour period. But we split the ratio where the 8 to 10 p.m. is charged at about 75 cents a kilowatt hour, or kilowatt, not a kilowatt hour, and 75 cents for the peak period. So it's basically equal. We had proposed hourly pricing. Con Ed had said their billing system couldn't handle hourly pricing, but this design is in further discussion with the Public Service Commission about maybe we would adapt this into other pilots that we're looking at moving forward. And what we have said is make this rate voluntary, so we have 50 megawatts of storage that can move into this rate. We allow the local utility to schedule, and we enroll them in a demand response program. So whether we're managing the building peak or to the network peak, we allow them to override and provide that resource in there. It's valid from 8 a.m. to 10 p.m. We think in the future, having a forecasted temperature adder as far as accelerating those prices over time has value. It could be very flexible to that because at the end of the day, temperature drives all things, whether it's on the cool side or even on the warm side. It can be flexible and adaptable to critical power events. Today, it's utilized valid Monday through Friday, but we think eventually this will just move to a 24/7, 365 value, and currently nights and weekends are at no cost. So what we've seen is that it's been well received by our end customers. It allows them to take advantage of this. It's based upon 90%, again, demand charges. We manage that system and we provide savings for the commercial account, and we're able to operate and reduce that load based upon price signals throughout the different peaking time periods within the Con Edison network. And so far, things look very encouraging. We're just getting customers moved on to that rates. The savings from customers look good. The encouragement from Con Ed as far as their non-wires alternatives and looking at their opportunities for eliminating hotspots is just going to expand even further using this sort of concept. So we like to say that, costs as we look at this in the distribution system are really capacity or demand driven. By managing the top 20% of load within a network, I think all ratepayers benefit from that. By looking at rate designs that take both time and locational effects into play has value. And making this voluntary, I think, is the best path to success, and being able to demonstrate and show people the benefits that how does this share across all ratepayers. And I look forward to your questions.
Doug, thank you very much. We'll go ahead and begin with staff. Howard, do you have any questions you'd like to ask?
James, I got a chuckle out of your observation that there's pilot fatigue, and we have a lot of pilots going. Some of them are successful and some of them are not. And I was wondering if you could give us a list of sort of like best practices in pilots, what makes them succeed, and just your thoughts. For example, you said one of them is that there's a lot of, I know we have a lot of lip service to scaling up, rarely get around to that. So if you could take us through what makes a good pilot.
Sure, yeah. I think, well, you just hit the scale one. I think really a lot of that comes back to the design of the pilot and ensuring that the pilot from the outset has an eye toward scale, which is not always the case, and has an eye toward the specific objectives that it's meant to achieve. And, you can design a lot of different things within that, but if it's tied to the right set of objectives and it has an eye towards scale and has actual steps laid out for how it's going to get to scale, assuming that it's successful at the end of the pilot duration, I think those are some of the key things that we've seen with pilots across the U.S. I mean, everything from rate design to smart grid to batteries, et cetera.
Anything else besides scale that we should look for?
Well, I mean, there's obviously the other components that have to do with the management buy-in and the right team in place. in the collaboration. The stakeholder engagement piece, I think, is probably one of the more complex ones to get right. I know that that's been a challenge here in Ohio with other types of stakeholder engagements. It's been a challenge in New York. It's been a challenge in California. But it is an area where some states are starting to have success on certain programs. I think in California, the More Than Smart initiative has been pretty successful for getting stakeholders together in a non-controversial or in a fairly amicable setting. So that's, again, one of the things that can kind of lead toward getting a good design. But having that intentionality around the design of the program is probably, the single biggest component to pay attention to, both in terms of the objectives, and one of those objectives is probably scale.
Tammy?
Yeah, just a couple. Nice to see you again, Paul. I have a question for Paul and also a question for James. Paul, regarding the subscription pricing, the demand subscription pricing that you were discussing, I guess it was in the European Union, I think. How does that relate to the customer charge? Is the demand subscription pricing, is it in addition to the customer charge, or is it in lieu of?
So we see this in at least a couple of European countries. I know Enel does it in Italy. Some of EDF, I think, does it in France. And I don't know offhand whether they also have a customer charge. One can imagine it being rolled into the subscription, and I don't know off the top of my head whether they also have a separate customer charge. Doug, do you know about Enel's practicing?
Not in detail, but those subscription charges are typically, based upon some sort of capacity or connected load,
Right.
much like a fixed charge.
Yeah,
I was just trying to figure out
and
if it was embedded,
Yeah.
in the demand pricing, or if it was in lieu, in lieu of.
I don't know the answer to that. I guess when I think about it, I would tend to think of, ultimately evolving to something more like you see in telecom, where you subscribe. If you go over for a brief period, there's an overage. I know historically, I don't know where Enel is today, historically where they did it is you had a demand subscription. If you used more than that demand for in excess of 30 minutes, you were disconnected and you had to actually turn things off before you could reconnect your service. I think we're probably a little beyond that now. But that's the kind of model where it gives you the flexibility, so you could have a base subscription that recovers a significant part of the residual cost, and still, based on equity and other considerations, decide how much incremental cost you want to associate with added subscription value.
Okay, thank you. James, this is a fairly easy question, and it perhaps was answered yesterday, and my apologies, I was not here yesterday. Regarding the Baltimore Gas and Electric program, where I think you said about 1 million customers had signed up, was that an opt-in or opt-out program?
Yeah, that was opt-in. To the best of my knowledge, there wasn't an opt-out component, but I'd have to look back to see if somewhere in the start of that they did have a sort of an opt-out component of it.
Anything specific that you could offer us in terms of, because customer education is obviously key, and as I think you have mentioned and others have mentioned, we have had some, time-based rates in Ohio, peak rebates that have been opt-in programs that have, some have been more successful than others. But I do think that customer education is key. So anything you have to offer us in terms of what happened in the Baltimore Gas and Electric scenario, that what they did from a customer education perspective that could give us some pointers?
Yeah, I think they actually did a lot of different things that could probably be incorporated. One was that they incorporated sort of a shadow billing or sort of a sample bill ahead of time to show customers how switching onto that would impact them. They did, let's see, what else? They did a fair amount of just direct outreach, paper outreach, I think also digital outreach to customers, both ahead of time. They did immediate follow-ups to show after sort of peak time events happened, to show them kind of what their savings looked like. So kind of that immediate feedback. With the peak time rebate, that's a little bit different than a time of use rate, how you might want to do that. But the point being that they sort of had like a call out to say, here's how this rate either benefited you in that case, or in a case of a time of use rate, maybe if you didn't respond, how it hurt you. So kind of that continuous feedback I think was one of the really effective things that they did to keep people engaged over time.
Thank you.
Yeah.
Yeah, Beth wants a quick follow-up, and then we'll go to Christina.
Sorry. So for the pilot, was it voluntary?
Yes. Yeah,
And
it
then-
wasn't mandatory.
Okay, and then what does the participation look like? And was yours voluntary as well? And then I'm just curious about participation in it.
Yeah, ours is voluntary, and we find that talking with commercial customers, if we can walk in and demonstrate what their bill is today versus what it would be under the program and there's savings, we find that people are very encouraged and very excited to jump on the rate. So we have not found it difficult to get customers on board.
Is there like a number that makes them excited? I mean,
Yeah.
is there any number,
There-
or is
there
it just
is.
a certain, is
There
there a
is.
certain tipping
Yeah,
point?
there is. Typically, when we work with commercial accounts and they look at their internal rate of return, anything that drives a rate of return that's somewhere in the low teens, usually you can get people to move forward. And with this rate design, with the differential and the price differential, we can achieve that very effectively. And based upon where they came from on the previous rate, it just drives additional savings and helps build that return.
Okay, thank you.
Other questions? Larry?
Yeah, we're at day 11 and 3/4, I think, by my math. And I want to go back to day one. Don't panic, it's not that hard. Day one, consumers were described as prosumers. We've talked about DER for every session, basically. The thought occurred to me, Paul, I guess, as you were chatting about rates, and I'm using rates and price synonymously, and maybe that's a fault to begin with, I don't know. But is price or rate symmetry essential in rate design? In other words, you can be selling an electron to a consumer, you could be buying an electron from a consumer when they become prosumers. Is symmetry necessary in this?
So in a market, you would expect price symmetry. That is, the value of, let's say, real energy at a particular location at a particular time in a pure market would be the same whether you're selling or buying. Now, there are some administrative market costs and things like that, but that's, how you allocate that is a slightly different question. But the price for the energy itself, you would expect to be the same. Now, I think, where you kind of hit on one of these issues that, that a rate can be a market-based rate, i.e. the equivalent of a price, or a rate can also be an administratively set rate. And if it's administratively set, of course, it can depart in many different ways from what the price would be.
Mr. Chairman.
Tom?
First of all, thank you all for being here, traveling to be here. And I think I understand this, but I was taken a little bit about in your conclusion, Doug, about the management of the top 20% of demand will result in savings for all ratepayers. I think I understand that, but I also think that that's probably a debatable subject. And I wondered if you would like to talk a little bit more about it.
You bet. So fundamentally, when we look at the costs that are associated with peak pricing, be it the ability to manage just in the distribution system. If you look at reconductoring occurs, especially in overhead, fundamentally anywhere from 150,000 a mile to 500,000 a mile. Reconductoring is typically done just because of peak loading. So if we're able to shape in a network that's just marginal as far as wire size, and we're able to shape that load and keep it under that next level of load that would drive the reconductoring is a decision based upon what you're going to see from losses over time versus the cost of a larger chunk of wire, lower resistance. And so that's just one element that we look at that I don't think we have dug in deep enough as far as we think about optimizing the distribution system to really understand how that cost avoidance would help all ratepayers. Because typically, a utility is encouraged by earning on capital deploy, and naturally, from a reliability standpoint, they would come to you and say, we find it economically beneficial to upgrade this line because it's going to reduce losses. But if you manage and shape the load, you may not incur that inflection point and may not need to do the upgrade. So there's a cost avoidance in managing that load just in a distribution side. When you look at the marginal cost of peak generation, and you look at a plant that runs basically maybe 17% of the time, which is 4 hours out of a day, every day that it peaks, that has a marginal cost that's somewhere between 20 and 30 cents a kilowatt hour for peak generation, but that's blended into everything. So as we get more granular across the different segments, being able to manage just the peak and take care of that influx, like in New York City, our top 1 gigawatt of usage at peak lasts 36 hours out of the year. The top 2 gigawatts, which is the output of 2 nuclear plants, is 156 hours out of the year. It's just the marginal cost is really out of whack with the base loading.
And one more thing, with your companies doing their work particularly in New York City, did you do that work for the utility or did the individual, or were you a third party?
Well, we're a third party
you are a
that
third
connects
party.
customers with their utilities.
Yeah.
And Con Ed's done a pretty good job of building a demand response program, so has New York ISO. They've made it very effective, so most of our customers are already used to load modification. So when we bring a storage element into that, we can do that transparently, which gives them a lot of relief. And what we see is as the grid requires more flexibility, if you can do that transparently and provide the utility with savings and the end user with savings, it's a win-win approach.
And I assume that there are others out there, you have competition,
We do,
I mean, like we do in Ohio.
you bet.
Yeah.
Yeah, so if you think about it, energy as a service or energy management as a service is an emerging market, and everybody is coming into this to say, let us come in and help you as a commercial or industrial customer manage that load more effectively. We're energy experts, you're good at your business, we'll manage that. And we have models where we'll come in and do a shared savings model. We'll pay to deploy the capital. We'll build a model that allows them to move into this, provide relief to the utility, get them what they're looking for, provide them savings, and splitting that savings without having to put any capital in play. And the one thing I would keep an eye on is that we're having really good discussions around these earning adjustment mechanisms in New York. So like being able to optimize and improve the distribution system utilization factor is a metric that we're looking at that they would be able to increase basis point earnings by optimizing those networks one by one. They're going to go in and measure the efficiency of all those networks and use that as a tool that they could drive another path to earnings rather than just earn on capital deployed.
Okay, any other questions? Dan?
Actually, I had a similar question to Commissioner Johnson's question, Doug. When I also looked at your conclusion and saw the second bullet point, and it raised a few questions for me. One is how you picked 20% to put in your conclusion, and they will result in savings for all ratepayers. You didn't have a qualifier in there, so I was wondering whether what you meant to say is something like management of the top 20% of demand, which is not hard to do, will result in a lot of savings for all ratepayers, or whether that's, or whether, I mean, I could have substituted 10%, 50% in your statement. I could have put in will result in minimal or a lot or whatever. How did you come up? What do you mean 20% will result in savings for all ratepayers?
As an energy geek, I look at a lot of load profiles, right? And I look at a lot of system profiles as well. What we have seen is, not sure what it is today, but typically, what we'll see in New York is this time of year, just about a 1.5, maybe 2 gigawatt peak based upon maybe a 14 gigawatt overall peak. And that peak will last. It's very triangular. It has a base that lasts for 4 hours. It ramps up, ramps down. And just all those resources that are built around that to build that peak, those have higher marginal costs. They're higher generation. They have higher losses in the transmission system, higher losses in the distribution system. In California, we see very similar ratios as well. So what we have seen is in most distribution systems, if you could manage that top 20% and manage that cost effectively, you would reduce or induce a lot of avoided costs or higher marginal costs. We've got 2 gigawatts of peaker plants in New York that are due to be retired. They're over 40 years old. And if we could just, 2 gigawatts out of a 14 gigawatt peak is about 15%. If we could manage that load and eliminate that, improve our air quality, those are the highest systems to operate, I think all ratepayers would benefit from that savings.
Okay, and then the other question I had was, when I was looking at that bullet point, is how do you go about doing it? And you just mentioned, I think, an interesting idea, which is to incent the utility to do what it otherwise would not be as inclined to do, which is to reduce consumption in order to achieve the goal by setting up a rate that provides a higher return, depending on improvements in capacity utilization for the
System
distribution
metrics.
system-wide
Right.
capacity utilization improvements.
Yeah, and what we do is we use price, and we just say, for the few, the willing, the brave, that are willing to expose themselves to market pricing, if you are willing to sign up for this rate that has, we like a ratio about 3-to-1 peak to off-peak as far as pricing. If we're willing to participate in that, and that gives us the right price signal, we're incented to reduce that load. That gives the utility the benefit. And in a storage-only model, we have to create that load somewhere. We would fill the trough a bit. We would start to flatten that load and improve the overall utilization of that network and defer a lot of assets over time. And remember, load, like heat, causes all assets to fatigue over time. So reducing and taking some of that heat out of the network, you get longer system life for all the equipment that's out there as well.
So you incent the customers by giving them a price break by getting off the peak when it's getting off the system or reducing demand.
What we see is if we move them onto that rate, if they didn't change their load, they would probably incur higher costs. But the fact that now we can manage that load more effectively, we can drive a lot of savings for them and give the utility the benefit that they're looking for as far as using price as that signal.
Howard?
Yeah, I just want to follow up on Dan's question. You would indicate that there's like a triangle, at the top, and that's where the savings are. Does that mean then if we got that 20%, we took care of it, that any savings beyond that will hit diminishing returns? In other words, is it really just the 20% that we have to induce to join into these programs that hit the sort of maximum results?
Well, I think what you start to get into then is you're starting to bump into more of the load following sorts of generation or even base load generation, which from a pure cost perspective is just much more efficient, right? So if you start to dip into, just a great scale, if you look at most peaking power plants use about 12,000 BTUs to produce a kilowatt hour. Most baseload generation, whether it's gas or coal, uses about half of that, about 6,000 BTUs. So if you looked at just from a fuel cost perspective or BTUs, it does start to get more marginal or less marginal as you go down the curve there. But also, remember, we're going to improve the usage overnight, and what's more important is we're going to have better utilization of the transmission system and better utilization of the distribution system, so that we don't need to continue to build to meet the peak as peak continues to climb. Even though I've heard multiple times that demand overall is decreasing, we still see increase in power usage, but overall or reduction in energy usage over time in a lot of networks.
Thank you.
Any other questions from anybody? Let's please give our panelists a round of applause. Thank you very much. Very well done. We will re-adjourn at 3 o'clock. Thank you.